so errors and uncertainties. We talked about random errors first of all. Random errors are the errors that cause your values to be different. So when you do an experiment, when you carry it out a number of times, it's very unlikely that you'll get a set of results that are exactly the same every single time. The reason for that is because of the different things that you do every time you're carrying out an experiment, the different things that can happen to make those results different. They are caused by things that we call random errors. So what we do is we take a series of values if we can, and then we average those out, and we reduce the error whilst we do that. Because if you've got a couple of values that are maybe a wee bit different from the rest, if most of the values are the same, then your average value, or your mean value as we call it later on, is going to take that into account. So we used background radiation. So if we look at this background radiation, there's a spread of values there. We take those values and we calculate what is really an average. We call it the mean value. We've got a little equation that we can use for calculating the mean value, and that's taking the total of all those values and dividing it by this n, which is the number of readings. So we figured out 21 counts per minute, and then we're thinking about how accurate is that answer. We need to take into account the spread of values that we've got. So we've got a value here of 26 and a value here of 17. We've got to take that spread of values into account. We do that by calculating what we call the approximate random error. And we only use that with repeated measurements. Repeated measurements of 5 and above is generally the norm for that. So we go for the approximate random error, which takes the maximum value minus the minimum value, divides it by the number taken. That gives us 2 counts per minute. And we then give our final answer, the mean plus or minus this margin of error. So that basically means that this mean background counts per minute can be anywhere in the range between 19 and 23. That's where that value is. So we've taken into account all the random effects there. Apart from random errors, there are a couple of other errors that we can be expected to consider. Systematic errors, that's basically some sort of error in the system, in the apparatus that you're using, that causes all values to be either too high or too low. That's not something we can account for like we can with the random errors, but it's something we need to know about. You've also got the reading errors, and that's just telling you how accurate you can be with your readings. You know, that again, it's human error. Plus or minus half a scale division in an analog scale, and we have plus or minus 1 in the least significant digit for a digital scale.